Good morning. Today we are going to cover section 3.4, graphing lines in standard form. So you should have your ruler, you should have all your materials ready, your ruler, your red pen, your highlighter, your glue stick, and most importantly, you should have your cutouts with you. If by any chance you do not have your cutouts, you can copy them down. Just go and pause it, just make a little box around it, and then you'll be set to go. First, we're going to start by making our margins, just the same way that we've been doing all this time. I'm going to place 6 squares, so therefore it'll be 2, 4, 6. You can do 5 if you have a larger grid, or you can also do 4 if you think it's taking too much space. So at this point, you should have it managed, right? So now the title is 3.4. And I'll get out of your way in a few minutes. Graphing lines in standard form. Let me make myself a little smaller. Why am I so large today? Here we go. Much better. So graphing lines in standard form. So the other in standard form and just singular. So the other way that we actually graph lines before was when we graph equations on lines in slope-intercept form. So first, before we actually get to graphing lines in standard form, we are going to use this cutout, 3.41, and we're going to go through the process. And you're going to use both, so therefore the first one is vertical and horizontal lines. So before we get to graphing lines in standard form, we are going to use this instead. Now, one of the things that we have to be careful is that we need to be able to recognize the difference between a vertical and horizontal line. So just make sure that we glue it, make sure that you get all the corners. So you do need to be able to memorize, and we need to also understand what makes a vertical line and what makes a horizontal line. So it's a combination of both. So the corners get glued nice and firm. Make sure that you line it up, and we are set to go. So whenever we have a vertical line, so pause if you need more time. If you don't have your cutout, you can go and pause it and just take the time to copy it down. Vertical lines versus horizontal lines. Whenever you have a comma 0, that means that, or x equal to a, that means that all the points on this line, the a value is the x value. So all those points, the x value is the a. So in this case, if this was 2 comma 0, each of the points, the x value will be 2. And therefore, the graph of the equation x equal to a is a vertical line that goes through the point a comma 0. And we'll go through an example right now. If it's a horizontal line, there will be y equal to the number. So therefore, if we have, for example, if we have y equal to 2, versus over here was x equal to 2, that means that every single point on the line, the y value will be 2. And a collection of all those points will make the line. But you do need to be able to remember that if you have x equal to a number, such as x equal to 2, that's going to be a vertical line. If you have y equals to a number, such as y equal to 2, that is going to be a horizontal line. So let's go through example number 1. graph. And when we graph, we are going to make a x and y axis, and we're going to make it 5 by 5. So the first one is a will be y equals 4. So therefore, I'm going to make a quick graph, a 5 by 5, 2, 4, 5. I'm going to make my halfway mark, 2, 4, 5, and then I'm going to make my halfway mark. Well, not my halfway mark, by my arrows. Now, 5 to the right and 5 to the left. So that's what I mean when I say a 5 by 5 graph. And for letter B, we're going to do the same thing. For letter B, we have x equals negative 2. So once again, I'm going to make a 5 by 5 graph, 2, 4, 5. And make my arrows. And now we are ready to graph. Go and pause if you need additional time. So then this means that the y value is 4. So we need to be able to get a collection of all the points whose y value is 4. So I know that this is my x and this is my y. And the y value is 4. So 1, 2, 3, 4. This point, the y value is 4. And we know the y values is 1, 2, 3, 4. So I'm going to collect all those points whose value are 4. Whose y value is 4. So therefore, this one is 1, 4, this one's 2, 4, this one's 3, 4, this one's 4, 4. And I can make my line all the way through, and that's it. That is the line of the equation y equals to 4, which means that all those points, that point is negative 4, positive 4. This point is negative 3, positive 4. This point is negative 2, positive 4. So all those points and all the points in between, the y value is 4. And that's what makes up the equation. And the same thing for the second one. For the second one, the x value is negative 2. So we know that this is my x-axis and this is my y-axis. So therefore, I'm going to locate x equals to negative 2, which is here. And I must go ahead and collect all the points whose x value is negative 2. So this one and this one. This one is negative 2 and 1. This one is negative 2 and 2. This one up here is negative 2 and comma 3. And all those points, the x value is negative 2. And therefore, we have the equation, the graph. So you have to remember that whenever you have y equals to 4 or y equal to a number, it's going to cross the y-axis at that specific value, and it's going to be a horizontal line. But if you have x equal to a number, it's going to be a vertical line, because all those points that are on the line, the x value is exactly the same. So that is horizontal and vertical lines. Now let's talk about standard form. But before, we have one more cut. You want to be able to paste that right here. So let's go ahead and take the time to glue it. And then we'll have a little more space underneath to write down the form of a standard, the equation of a standard form. So make sure that you get all your corners. Glue everywhere in between. And just make sure that you do it nice and neat. When you do it, just measure first, and then once you're set, go and commit. Sometimes I need to redo my corners. So therefore, every single time you're trying to find your intercepts, we have two intercepts. We have your x-intercepts, and the x-intercept of a graph is the x-coordinate of the point where the graph crosses your x-axis, right? Crosses, intercepts. So therefore, this is your x-intercept. And it's going to have a comma 0, where the a is any number. Your y-intercept of a graph is the y-coordinate of a point where the graph crosses the y-axis. So therefore, we need to be able to find where the graph crosses your x-axis and y-axis. And to be able to find where it crosses your x-axis, it's going to occur when the y value is 0, correct? And to find where it crosses your y-axis, your y-intercept is going to occur when the x value is 0. So those are two key things. When the y value is 0, that'll be your x-intercept. When your x value is 0, that'll be your y-intercept. Now, let's go and write down the equation for the standard form. The standard form, you guys will usually see as follows. It's going to be a x plus by is equal to c, where a, b, and c are going to be real numbers. So such as one example will be 2x plus 3y equal to 6. That is the standard form of a linear equation. The other form that we had seen was the y equals mx plus b, so slightly different. So let's go through and go through example number 2. On example number 2, we are going to graph an equation of a line. And I'm going to use the right-hand side of my notes. And I'm going to place 6 or 7 squares. 2, 4, 6, 7. So this will be perfect. And we're going to write down example number 3. Use the intercepts to graph the equation. So we're going to use the x-intercepts and the y-intercepts to be able to find the equation, to graph the equation. So use the intercepts to graph, and we have the equation is 3x plus 4y equal to 2. So therefore, what we want to do, we want to be able to make it x and y axis, and we're going to make it 5 by 5. I'm going to make it on the right hand side, and then I'm going to use the space on the left to find the x and y intercepts. So let's go make it 5 by 5. So 2, 4, 5, 2, 4, 5. And I need to be able to find both intercepts. I need to be able to find the x-intercept and the y-intercept. And I'm going to abbreviate it as int and int, so it gives me a little more space. So according to our cutout, if we go back and revisit our cutout, it says that the x-intercept is going to be found when y equal to 0. So therefore, in order to be able to find the x-intercept, we are going to let y equal to 0. And you do need to write this down. You need to be able to write down in red. To find the x-intercept, we're going to let y equals to 0. Now, if you notice, to find your y-intercept, it's going to occur when x equals to 0. So therefore, in order to find your y-intercept, we're actually going to let x equals 0. So to find your x-intercept, you let y equal to 0. To find your y-intercept, you let x equal to 0. So the opposite. The x-intercept, y equal to 0. Y-intercept, x equal to 0. So let's go start with the x-intercept. I'm going to use the same equation. I'm going to use this equation that we have here. And I'm going to replace, instead of the y, I'm going to replace it with the 0. So let's write down 3x plus 4. Instead of the y, I'm going to replace it with a 0. And notice that I'm doing the same thing that we've been doing. Every time you do a substitution, you're going to plug in 0. 4 times 0 is 0, so that cancels out. And we have 3x equals to 12. And now to leave the x by itself, we're going to divide by 3. So now we can solve it. So therefore, x equals 12 divided by 3 will be 4. This is going to be the x value, but remember that your x-intercept is going to be a point. So therefore, you must write it down as a point. I'll place a point here. Your x value is 4, and your y value is 0. And now we can plot it. 4 to the right, 1, 2, 3, 4, and then I must stay there. That is where it crosses the, so therefore your line, which is here, is going to cross at this point. So now I just need to be able to find where is it going to cross on the y-axis, and then I can make my line. So that's what we're going to find here. 3, instead of the x, we're going to replace it with a 0. So notice that the only thing I want to do to find the y-intercept, I'm going to plug in a 0 instead of the x. 3 times 0 is 0, so that cancels out. So now I have 4y equals 12. And the last step is to divide by 4. Divide by 4. My 4's cancel, so therefore y equals 3. Remember that your y-intercept is going to be a point. So you do need to be able to write it down as a point. Your y value is 3. And what is the corresponding x value? 0. So therefore, that means I'm going to stay here in 1, 2, 3. Since the line crosses this point, and the line crosses that point, now that we have 2 points, we can just connect them. And that is the equation of the line. And I know what you're saying. I said, hold on, Diaz. But didn't we learn this before? We did it in a different way. So the other way that we did it, and actually, let me just do it on the left-hand side. We have enough space. So if you have 3x plus 4y equals to 12, and the way that we graphed it before is by leaving the y by itself. So to rewrite in slope-intercept form, we move this to the right. We can't say negative. So we have 4y equals negative 3x plus 12. Divide by 4, divide by 4, and divide by 4. So now the y equals negative 3 over 4x plus 3. And we graphed it by placing the y-intercept, which is 3. And the slope is down 1, 2, 3, and 1, 2, 3, 4. And you get the same answer. So those are 2 different ways of graphing it. So therefore, if you decide, you can graph an equation by leaving the y by itself. 2-step process. Move the x to the other side. You can say negative. Then divide by 4, divide by 4, divide by 4. And that gives you a new equation. Your y-intercept is 3, and then your slope is down 3 and to the right 4. Or the other way of doing it is to be able to find your x-intercept, plot it, find your y-intercept, you plot it, and then connect it. And you get the same graph. Now remember that we actually did it another way on 3.1, where we made a table of values, and we just plug in values for x. All three methods are valid. Sometimes this method might be easier. Sometimes this one, some people prefer. I prefer this one here. But there's going to be some times that we do need to be able to find your x and y intercept. And that's why we're doing this method. I know what you're thinking, like, really, yes, do I need to do all three ways? Yeah, you need to be able to plot points. You need to be able to solve for y. And you also need to be comfortable finding your x and your y intercept. Example number 4. Use the intercept. And notice that's very specific. It doesn't say to graph. Now, if it says to graph, you can actually decide which way you want to solve or to graph it. Use the intercepts to graph. And the equation that we have now is x minus 2y equals to 6. So let's go and build a 5 by 5 graph. 2, 4, 5. And now I need to be able to find the intercepts. So therefore, I want to find my x-intercept and the y-intercept. Now, how do I find the x-intercept? To find the x-intercept, we're going to let y equal to 0. And to find the y-intercept, we're going to let x equals 0. I do need to see that in red, so you should have your red pen, because that's going to help you remember, and that's what we're trying to do. We're trying to make it easier so you can remember the information, and your brain doesn't have to work as hard. So now, let's go and find, if you need more time, go and pause it before we continue. To find your x-intercept, you're going to let y equal to 0. So therefore, we have, I'm going to replace the y with the 0, and I'm going to set it up first. X minus 2y equal to 0. But instead of the y, I'm going to replace it with a 0. Negative 2 times 0 is 0, so that disappears. We have x equals 6. To find the y-intercept, you're going to let x equal to 0. So now, instead of the x, I'm going to replace it with a 0. So 0 minus 2y equals to 6. But now the x becomes a 0. Anything that's 0, that disappears. So now we have negative 2y equals 6. And one last step is to divide by negative 2. My 2's cancel and my negatives cancel, so therefore y equals negative 3. Now remember that each of them is not a x value. Whenever you find your x-intercept, it's a point. The x value is 6, and the corresponding y value is 0. And in this case, your y value is negative 3, so that's a point. And the corresponding x value is 0. So therefore, I'm going to plot them, and then I'm going to connect them, and that will be my line. 6, 1, 2, 3, 4, 5. One more 6, and 0. This one is going to stay there, and then down 3. So therefore, my line will be connected. And that's on your test, you'll have to do the same thing. There'll be an equation that you need to decide whether you need to be able to find your x and y intercept, or you can do it just like we did it before, by solving for y. But there's going to be other questions where I'm going to ask you to find your x-intercept or to find your y-intercept, and you have to show me the correct one. The last example for today. See if you can do this example by yourself. And then we can Otherwise, we can work it out together. So example number 5. Use the x-intercepts to graph. Not the x-intercept, just the intercept, because we need to be able to use both the x and y. We have 2, 4, 5. And the equation that we have is uh, 5x minus 3y is equal to negative 15. Go ahead and try it. Find your x-intercept. Find your y-intercept. And see what you get. And then we can compare our answers afterwards. Go and pause it. You got it? Are you sure? Perfect. So now to find your x-intercept, we're going to let y equal to 0. And to find your y-intercept, we are going to let x equal 0. And now let's go and plug in a 0 instead of the y. We have 5x minus 3, y equals negative 15. But instead of the y, I'm going to replace it with a 0. Negative 3 times 0 is 0. So we have 5x equals negative 15. And now the last step is to divide by 5. Divide by 5, divide by 5. My 5 cancels, so therefore x equals negative 3. And now I need to be able to find my y-intercept. That'll be, I'm going to plug in a 0 for the x now. So we have 5x minus 3y equals negative 15. And I'm going to plug in a 0. 5 times 0 is 0. So that cancels. Negative 3y equals negative 15. Divide by negative 3. Divide by negative 3. My 3's cancel, my negatives cancel, so therefore we have y equals to 5. And positive 5. Remember, negative divided by negative, you're using a triangle, so negative divided by negative gives me a positive. But you do need to write them down as a point. My x value is negative 3. My y value is 0. In this case, my y value is 5. And the corresponding x value is up there, 0. And now we can plot it. To the left 3 and 0, 0, and then up 5. From here, I'm going to make my line. And that's it. So the other way of doing it, so let's say that you wanted to do it the other way, is to be able to solve for y. So I'll just do a little sticky note on the left hand side. So let's say that you wanted to be able to do it the other way by using the slope and the y-intercept. I'll move my 5x to the right, becomes a negative 5x. So therefore that'll be negative 3y. That's a positive, becomes a negative 5x minus 15. Then I divide by negative 3. Divide by negative 3. And divide by negative 3. My 3's cancel, my negatives cancel, so therefore we have y equals. Negative divided by negative is going to be a positive, and my slope is positive. So 5 over 3 x. Negative divided by negative is going to be a positive, so positive 5. So from here, my y-intercept is 5, and my slope is 1, 2, 3, 4, 5, 1, 2, 3. And notice that, oh, I went off. 1, 2, 3, 4, 5, and 1, 2, 3. So even if I extend it to that point, that's still the same equation, the same graph. But for today, we are learning to find the x and y intercepts, which is an essential part of algebra. So this will conclude the lesson for today. Have a great day and email me if you have any questions.